Yes, we can hear you, Dr. Harun.
Tapi dalam tempoh PKP tu rasa sekarang
Okay, thank you, Dr. Harun. Assalamualaikum and a very good morning to everyone in Malaysia. And hi to everyone outside from Malaysia. Can you all hear me clearly? Okay.
Yes.
Okay, thank you. So, as what Dr. Harun briefly mentioned just now, this program is organized by UiTM Student Branch in conjunction with the IEEE PES Day. Okay, so before I pass the session to our speaker, Dr. Rahimi, so let me just briefly introduce our student branch, which is UiTM. Okay, let me just share my slide. Okay, so this is Universiti Teknologi MARA, or in short, it is UiTM. It is located in Selangor, west of Peninsular Malaysia. This is our Dean for the Faculty of Electrical Engineering. Okay, Faculty of Electrical Engineering is located at the Engineering Tower in UiTM. We have twin tower for engineering faculties, where we share 2 towers with 4 engineering faculties. Okay, so Faculty of Electrical Engineering is in tower number 2. Okay, so this is our location. And for the IEEE UiTM Student Branch, okay, these are some of the student branches in Malaysia. Okay, so for IEEE UiTM Student Branch, I am the counselor and assisted by technologist Dr. Suhaila Subahir. And this is our top management for UiTM Student Branch. So basically, these students are final year students, except for our Vice Chair too. He is semester 4. And this is the Executive Committee for the IEEE UiTM Student Branch session 2019-2020. And basically our focus is on academic programs, humanitarian, entrepreneurship, and social activities. So these are some of the past year activities that we have conducted. And this is the coming for this year's activity. So in conjunction to the IEEE PES Day, UiTM Student Branch participated in 4 events. So for today's event, which is the MATLAB for beginner, it is the second program that UiTM Student Branch organized. So these are our social media. We have Facebook, Instagram, and also our website. Okay, so that's all from me on the IEEE Student Branch. Okay, before I pass to Dr. Dr. Rahimi, let me just briefly introduce our speaker. Engineer Technologist Dr. Rahimi Baharom is currently the chair of IEEE PELS Malaysia Power Electronics Chapter, PELS. Throughout his journey, he took part in various projects and achieved many awards. His publication has helped many people on their researches. He is currently working on a project funded by Lestari entitled Cyber Security Detection Strategy in Smart DC Microgrid Operation. Along the journey, he has mastered the utilization of MATLAB software and willing to share his knowledge with others. Okay, without further ado, I will pass the session to IR Dr. Rahimi. And before that, if anyone have any questions, you are feel free to just write in the chat box, and either Dr. Rahimi and I will share the questions. Okay, Dr. Rahimi?
Okay, Dr. Shida, thank you very much.
Okay.
Okay, Assalamualaikum and good day to everyone. First of all, I would like to thank the organizer of IEEE UiTM Student Branch in collaboration with IEEE Malaysia Power and Energy Society and IEEE Malaysia Power Electronics Society for inviting me to share some knowledge on MATLAB simulating. Okay. Alright, so before we proceed to MATLAB program, just give me 2 or 3 minutes, okay, to talk about IEEE. Dr. Ashida, I cannot share my document. Okay. Okay, ladies and gentlemen, IEEE actually pronounced IEEE. Okay, IEEE. Okay, pronounced IEEE. Okay, which is stand for the Institute of Electrical and Electronics Engineers. Okay, and the association is chartered under this name, and it is the full legal name. And why IEEE actually? Okay, not the other society or professional bodies. Okay, for your information, the IEEE is the world's largest professional association, advancing innovation and technological excellence for the benefit of humanities. And IEEE is the trusted voice for engineering, computing, and technology information around the globe. Okay, basically there are more than 430,000 IEEE members in more than 160 countries. And benefit of membership, okay, to become IEEE members. Okay, IEEE delivers access to the industry's most essential technical information, networking opportunities, career development tools, and many other exclusive benefits to its members, right? And for member grade elevation, for example, as a student, you can join IEEE as a student member. Okay, and then after you graduated, you can upgrade your membership, okay, to be a member of IEEE. And then after 5 years, you can upgrade to become a senior member, and then fellow, and etc. Okay, so come and join IEEE. Okay, there are a lot of benefits, okay, to be IEEE members, right? Okay, let's start our MATLAB program. Okay, actually for your information, this is the 11th year of MATLAB program, okay, that I have conducted, right? So where the first program was held in 2009. Okay, so this is the first batch, okay, for workshop on MATLAB Simulink program. Okay, and then after that, every year we organize MATLAB program, okay, until this year. And this is for the last year, okay, workshop on MATLAB Simulink, which was held on 27 March 2019. Right, so we organized at Faculty of Electrical Engineering, UiTM Shah. Okay, so if you have any question, you can ask me directly, right? So basically, before we start with MATLAB Simulink, let me introduce about MATLAB software, right? So the power system block set simulation tool use the MATLAB Simulink. Okay, use the MATLAB Simulink environment to represent common components and devices found in electrical power networks, right? So it consists of a block library that includes electrical models such as a resistor, inductor, and capacitor branches and loads, transformers, lines, such arrestor, electric machine, power electronic devices, and etc. And power system block set libraries, okay, contain basic elements as well as many ready built subsystems. Okay, what is subsystem? I will brief later. Right? And diagrams can be assembled simply by using click and drag procedures in Simulink windows. Okay. And power system block set, okay, use the same drawing and interactive dialog box to enter parameters as in the standard Simulink blocks. For example, when we choose or select a resistor, we have to set the value of resistor. And the power system block set graphical interface also includes an interactive tool to set initial condition of capacitor voltage and inductor currents, okay, in order to perform steady state condition and etc. And simulation result can be visualized with simulating scopes, okay, similar with when we perform experimental test rig at laboratory, okay, we use oscilloscope. In MATLAB, we use simulating scopes, okay, which is connected to output of measurement blocks available in Power System Block Set library. And we can perform this measurement blocks as an interface between electrical blocks and the simulating blocks. And voltage and current measurement, okay, can be used in at selected points, okay, in the circuit to convert electrical signals into simulating signal, right? And the user can access a variety of MATLAB function and toolbox for processing and plotting of waveforms stored in the MATLAB workspace. And the computation capabilities of MATLAB simulating can be advantageously exploited in post-processing of the simulation result. Okay, so in this workshop, MATLAB simulating workshop, okay, we will discuss on how to model basic electrical circuit or electronic circuit, and how to analyze, okay, the waveform from current and voltage. Okay, so this is hands-on workshop. Okay, so I hope everybody can ready with your tools. Okay, so to start with MATLAB simulating. Okay, so this is the shortcut for MATLAB simulating. Okay, so to open MATLAB Windows, so just double click at this shortcut. Okay, so after you click at MATLAB shortcut, and it will appear MATLAB Windows. Okay, MATLAB window. So this is the window. Okay, everybody can hear me or not? So far, okay?
Yes, clear.
Clear? All right. Okay, so to start with simulating window, okay, so just click at file. Okay, just click at file, and then you select new. Okay, then you select model. Okay, first click at file, and then select new, and then you have to select model. Okay, in order to open simulating window. Right, so when you select window model, then it will appear simulating window. So this is our simulating window. So we will model our electronic and electrical circuits. Okay, so at this window. Okay, so how to model MATLAB electrical or electronic circuits using MATLAB. Okay, so first we have to find components or devices that we have to use. So where to find components or devices in MATLAB simulating? Okay, so you can find at simulating library brochure. So this is the symbol for simulating library brochure. Okay, so just click at simulating library brochure. Okay, so this is simulating library brochure dialog box. Okay, so we can find any components or devices in simulating library brochure. Okay, so how to find it? Okay, first to search the component. Okay, if you know the name of components, so you can type name of components here. And then after you type the name of component or devices, okay, you click at this symbol. Okay, click at this symbol. Okay, so if you don't know the name of components, okay, it's okay. So you can find it manually. Okay, you can find it manually. Okay, you check the components one by one. Okay, in Simulink Library brochure, you can click plus symbol. Okay, to find components or devices in Simulink Library brochure. Okay, right now we want to build a simple model. Okay, simple circuit model. Right, so first you have to go to Simulink Library brochure. Okay, and then you click at Sim Power System. Okay, Sim Power System. Okay, at Simulink Library brochure. Okay, click at Sim Power System and select electrical sources. Okay, you can select electrical sources. Since you select electrical sources, it will appear several types of electrical sources. So we have AC current source, AC voltage source, control current source, control voltage source, DC voltage source, and also three-phase sources. Okay, so for this example, okay, please select AC voltage source. Okay, please select AC voltage source at Simulink Library brochure. Then, since you select AC voltage source, then just perform click and drag procedure. Click at Simulink components or devices at Simulink Library brochure. Then drag to Simulink windows. Okay, click and drag. Okay, just perform click and drag procedure. Okay, to copy devices or components from Simulink Library brochure to Simulink window. Okay, so we have AC voltage source at Simulink window. Okay, so you can set the parameters of AC voltage source. So how to set the parameters? Just double click at the component. Okay, just double click at the component and just set the parameters value. Okay, for example, P amplitude. Okay, just set 100. Phase degree, just set 0, and frequency. Okay, for example, in Malaysia, our fundamental frequency 50 Hz. Okay, you can set here 50 Hz. Since you set all of these parameters, then you click OK. Okay, then you click OK. Okay, and we would like to find another components. Okay, in Simulink Library brochure. Okay, go to Simulink Library brochure. Okay, select elements. Okay, select elements at Sim Power System. Okay, under Sim Power System. Okay, you select element. Then you select series RLC branch. Okay, we have RLC. Okay, you select RLC branch. So RLC actually for resistor, inductor, and capacitor. Okay, just perform click and drag procedure. Okay, to copy this component from Simulink Library brochure to Simulink window. Right. So we have RLC branch in our Simulink window. Okay, for example, okay, so we don't need to use all of these three components, okay, resistor, inductor, and capacitor. We just need to use resistor only. Okay, so how to set resistor only? So just double click at the component. Okay, it will appear this dialog box. Okay, and you can choose types of component. Okay, by click at this symbol. Okay, so since you click at this symbol, then it will appear. Okay, branch type. Okay, we have RLC, single resistor, single inductor, single capacitor, the combination of resistor and inductor, combination of resistor capacitor, LC, and open circuit. Okay, so for this example, we just need resistor only, single resistor only. Then you select resistor R. Okay, you select R. Then look at simulating window. Okay, from RLC branch, it just appear resistor only. Okay. Right, then we can set the parameters for this resistance. Okay, let's say you set 1000 ohm. Okay, just set the parameters 1000 ohm. Since you set the parameters 1000 ohm, then you click OK. Okay, click OK. Then you can rearrange the component. Okay, you can use command Control R. Okay, to rotate the position of each component or devices. Okay, so rearrange the component. We have AC voltage source and we have resistor. Okay, at simulating window. Okay, so now how to measure the voltage or current? Okay, so to measure voltage and current, we have to use voltage and current measurement. So how to find it? So go to simulating library brochure. Okay, just go to simulating library brochure. And then you select sim power system. Then you select measurements. Okay, select measurements. Since you select measurement, it will appear current measurement, impedance measurement, multimeter, three-phase voltage and current measurement, and also voltage measurement. Okay. Alright, so in this example, we want to measure voltage and current. So you just select current measurement. And as usual, just perform click and drag procedure. Okay, just perform click and drag procedure. So we can see here, there are current measurement in simulating window. Then select voltage measurement. Okay, you can select voltage measurement and click and drag procedure. Okay, just perform click and drag procedure in order to copy voltage measurement from simulating library brochure, okay, to simulating window. Okay, so now at simulating window, so we have AC voltage source, current measurement, resistor, and voltage measurement. Okay, so how to connect the components, okay, or how to perform wiring procedure. Okay, so first you have to rearrange all of these components. Okay, please rearrange all of this component. And to perform wiring procedure, just click at the component. Just click the point of each component. Okay, at each component, it has connection point. So this is connection point for AC voltage source. And this is connection point for current measurement. Just click at this point and then click at until this point. Then you can perform wiring procedure. Okay, you can connect all of this component. Okay, so please take note, if you want to measure current, you have to arrange current measurement in series connection. And if you want to measure voltage, you have to arrange voltage measurement in parallel connection. Okay. Clear? Right. So this is the circuit connection after we perform wiring to all components. Okay. So we have AC voltage source, current measurement, resistor, and voltage measurement. Okay. So now how to observe the current or voltage waveform? So we have this circuit and how to observe voltage and current waveform. Okay, so similar when we perform experimental works, okay, we use oscilloscope to observe voltage or current waveform. Okay, in MATLAB Simulate, okay, we use scope. Okay, so how to find scope? Go to Simulink Library brochure. Okay, then you click at Simulink. Okay, at Simulink Library brochure, just click at Simulink. Then you select sinks. Okay, you select sinks. Since you select sinks, then it will appear scope and etc. Okay, for this example, you select scope and just perform click and drag procedure. Okay, for example, we want to measure or observe voltage and current waveform. So we need to scope. Okay, just click and drag scope. Okay, to scope, or you can copy and paste scope from Simulink window. Okay, so since click and drag scope to Simulink window, then we have to set the scope. Okay, so how to set the scope? Just double click at scope. Okay, just double click at scope. Then you click at parameters. Okay, click at parameters. Okay, click at parameters and it will appear this dialog box. Okay, scope parameters. Right. And at sampling, okay, we can set sampling time. Okay, so at sampling, you can set sampling time. Okay, just set 0.000 something, 0.001 for example. Okay, so 0.00 means that how precise your waveform. Okay, will be appear in the scope. Okay, so the more zero here means that the more precise your waveform in scope. Okay, so click at sample time and set 0.0001. Then click OK. Okay. Then click at general. Okay, at scope, click at general. Okay, so you can set sample time as I mentioned just now. And if you click at data history, Okay, click at data history. Take save data to workspace. Okay, click save data to workspace. And then variable name, you can rename your scope, for example, current or voltage scope. Okay, IV or IS. Sorry, V out or IS. Okay, so you can rename scope data. Then you click OK. Right? Okay, so now how to set the simulation time? Okay, so first you have to connect scope to current measurement and to voltage measurement. Okay, so just connect to symbol V, point V, and the other scope you just connect to symbol I for current measurement. If you have any question, you just ask me. Okay, unmute your mic and then you just ask. Okay, if you have no question, I just proceed. Right. Okay, so how to set simulation time? Okay, for example, we want to simulate this circuit in 2 cycles. Okay, 1 cycle. We have set a frequency at AC voltage source 50 Hz. Okay, means that 1 cycle equals to 0.02 second. Okay, for 2 cycle, we have to set simulation time 0.04. Okay, 0.04 means that we want to simulate this circuit in 2 cycle, 2 full cycle, I mean. Okay, just set 0.02, 0.04. Okay, for simulation time. Okay, so now click at simulation. Okay, click at simulation and select configuration parameters. Okay, so you have to select configuration parameters. Okay, since you select configuration parameters, it will appear this window. Okay, so this dialog box. Okay, so we have to set solver. Okay, so click at solver. Okay, click at solver. Then you select ODE 23S. Okay, select this solver, ODE 23S. Okay, then you click OK. Okay, then you click OK. Right, so don't forget to insert power GUI. Okay, so how to find power GUI? Okay, just go to Simulink Library Brochure and search POWER GUI. Okay, power GUI. Okay, for the latest MATLAB version, you have to include or insert power GUI. Okay, before you simulate your circuit. If not, you cannot simulate your circuit. Okay, at Simulink Library Brochure, so please find power GUI and just click and drag procedure. Okay, copy power GUI from Simulink Library Brochure to Simulink Windows. Okay, so we have power GUI. Okay, in simulating window. So now ready to simulate your circuit. Okay, so how to simulate your circuit? Okay, so just click play or run button. Okay, just click play or run button. Okay, since you click play and run button, and how about the waveform? Voltage and current waveform. Okay, so to observe voltage and current waveform, just double click at scope. Okay, just double click at scope. Okay, for example, if you double click at voltage scope, okay, so it will appear output voltage. Okay, means that voltage across the resistor. So this is the waveform. Okay, this is the output voltage waveform. Okay, so everybody get it? And this is the supply current waveform. Okay, AC waveform. So any questions so far? So everybody get this waveform?
There is one question
Yeah.
from Ali Hamad. He asked, wires are appearing red for me. Is that normal?
Not normal. So means that there are some problem with your wiring system.
Okay, okay, that's
Okay, any other question?
okay. Another question. Current waveform is in ampere or per unit?
Sorry?
Current waveform is in ampere or per unit?
This is in voltage, V, current ampere,
Okay,
in ampere.
ampere. Okay.
Yeah.
So any other question?
For the ampere.
No, not yet.
Alright, so I hope everybody get this waveform. Okay, voltage and current waveform. Okay, if waveform do not appear in your scope, so means that there are problem with your scope. Okay, so you have to set parameters at your scope actually. Okay, just set parameters at the scope. Okay, now how to copy the waveform from MATLAB Simulink to Microsoft Word. Okay, to insert a simulation result into your report, technical report, thesis, and etc. Okay, so how to copy the waveform from MATLAB Simulink to Microsoft Word. Okay, so first we have to set scope. Okay, the scope, we have to set the scope. Okay, just double click at scope. Okay, click add parameters. Okay, you have to click add parameters. Okay, and click add data history. Okay, click add data history. And you take save data to workspace and add format, you select array. Okay, add format, you select array. Then click OK. Okay, then you click OK. Then you have to run your simulation circuit again. Okay, just click run or play button. Okay, then go to MATLAB Windows. Okay, go to MATLAB window. And add workspace. Okay, add workspace. You can find your scope. Okay, your scope. Okay, you can find your scope. Okay, let's say your scope name scope data 1. Okay, scope data 1. So just right click at scope data 1. if you rename vout or is, you just right click at vout or is. Okay. For this example, just right click at scope data 1. Okay, so since you right click scope data 1, it will appear this dialog box. Okay, then you select plot all columns. Okay, you have to select plot all columns. Then it will appear this figure. Okay, this figure. For example, this is the supply current waveform. Okay, for the circuit that we have simulated just now. Alright, so click at edit plot. Okay, click at edit plot symbol and double click at add axis. Okay, just double click at add axis. Okay, so just remember, okay, we have set our simulation time, right, from 0 to 0.04. Okay, from 0 to 0.04 second. Okay, so means that we simulate our circuit in 2 full cycle operation. Okay, but in this figure, it appear this parameter from 0, 50, 100, and up to 450. Okay, so we want to reset these parameters. So how to reset these parameters? Just double click at add axis. Okay, since you double click at add axis, and okay, so it will appear add axis. Okay, so look at X limit. Okay, X limit just set from 0 to, at this figure, up to 450. Okay, 450. So now change the X limit from 0 to 400. Okay, up to 400 only. Then you click enter. Okay, then you click enter. Since you click enter, then look at the supply current waveform. Okay, it starts from 0 up to 400. Okay, 400. Alright, so we want to remove this waveform. Okay, just click at blue line, then you click delete. Okay, select or click at blue line, this line, then you click delete. So we don't want that waveform. Okay. Then we want to set x-axis parameters. Okay, so click at x-axis. Okay, then to change the parameters of x-axis, okay, so please click at ticks. Okay, just click at ticks and it will appear this dialog box. Okay, so location and label. Okay, so this is auto. At stick location auto. Okay, so just select manual. Okay, so just select manual. And then you can change all of the parameters at labels. Okay, so we know that our simulation time from 0 to 0.04. Okay, 0.04. So means that you can change all of the parameters at label. Okay, so these parameters. Okay, so how to change it? Okay, so just insert new parameters, new values. Okay, for example, you just replace 50 to 0.005. Okay, and 200 to 0.02. So this is for one cycle. And 400 to 0.04. So it means that we simulate this circuit for 2 cycles. Okay, 2 full cycle. Okay, so you can change this label. Okay, since you change all of this label, then you click apply. Okay, click apply and then click OK. Okay, then look at the exist parameters. Okay, so the parameters actually according to the values that we have set just now. Okay, from 0 up to 0.04 second. Okay, then you can set background color. Okay, how to set the background color? Just click at gray area. Okay, just click at gray area. And you can select figure color. Okay, you can select figure colors. Okay, so let's say if you want to set background white. Okay, then you select background color. Okay, then you click OK. Okay, then look at the background color. Okay, from gray we have changed to white. Okay, that's the procedure how to change background color. Again, just click at exist. Okay, just click at exist, and then at grid. Okay, you can take X and Y. Okay, you can take X and Y. Okay, in order to insert grid. Okay, to your waveform. Okay, so if you take X and Y, then look at this figure. Okay, so it consists of X and Y grid. Okay, and how to change the color of this waveform. Okay, so to change the color or to set the width of this waveform, just click at the waveform. Okay, you just click at the waveform and you can click at colors. Okay, you can click at colors and you can set the colors for supply current waveform. Okay, let's say if you set to red color. Okay, then you click OK and look at the waveform. Okay, change from black color to red color. And you also can change the width of this waveform. Okay, just click or select line width. Okay, just select line width. Then you can select line width. Okay. Okay, for example, if you select 3, okay, so you can see the waveform. Okay, so the width actually change. And click at white area. Okay, so this is the supply current waveform. Okay, so now how to copy this waveform from MATLAB Simulink to Microsoft Word. Okay, so just click at edit and then you can select copy figure. Okay, you can select copy figure and then at Microsoft Word, okay, Microsoft window, then you can click edit and then select paste. Okay, so your figure actually will appear at Microsoft Word. Okay, so that's how to copy figure from how to copy waveform from MATLAB Simulink into Microsoft Word. Okay, clear? So any questions so far? No question, eh? So we just proceed. Measurement using MATLAB Simulink. Okay, So we have discussed just now how to observe voltage and current waveform and how to copy waveform from MATLAB into Microsoft Word. Okay, so now how to measure the voltage and current using MATLAB Simulink. Right? So as usual, so all components or devices are already in Simulink library brochure. So just click at Simulink library brochure. Okay, go to Simulink library brochure and click at Sim Power System. Okay, click at Sim Power System. And at Sim Power System, you select measurement. Okay, please select measurement. Since you select measurement, it will appear current measurement, voltage measurement, okay, as we have been discussed just now. Okay, then just insert current measurement and voltage measurement. Okay, we already insert just now. Okay, click and drag procedure. Okay, so go to Simulink library brochure and select Simulink response optimization. Okay, at Simulink library brochure, select Simulink response optimization and select RMS blocks. Okay, so you can select RMS block. Okay, so it will appear continuous RMS and discrete RMS. For example, if you want to measure using continuous RMS, you can select continuous RMS. Okay, continuous RMS. Okay, so just click and drag procedure. Continuous RMS. Okay, from Simulink library brochure into Simulink window. Okay, so we have continuous RMS. Okay, block set. Okay, in our Simulink window. Okay, so again, go to Simulink library brochure and then select sinks. Okay, select sinks and select display. And then click and drag procedure. Okay, so just perform click and drag procedure. Okay, so rearrange continuous RMS block and display block and then do wiring connection. Okay, so do wiring connection like this. Okay, from current measurement, connect to continuous RMS, and from continuous RMS block, connect to display block. Okay, then just click at run simulation, run or play simulation. Since you click at run or play simulation button, so you can see measurement with parameters at display. So this is the value of supply current, 0 point something. Okay, right? So that's the procedure how to perform a measurement using MATLAB Simulink. Right? Any other question? Any question so far?
Okay, there are 3 questions.
Yeah.
The first one, in what situation do we need to use discrete RMS measurement?
Mm-hmm.
Okay, another 2 is from YouTube.
Mm.
What if there is some missing component in the library?
What are?
What if there is some missing component in the library?
Okay. Then?
Okay, another one, the participant request for Dr. Rahimi's contact number lah. I think later we can give your contact number or
Email. Yeah.
okay. So there
Okay.
are 2 questions.
Alright. So first question, how to use continuous or discrete RMS, right?
Mm.
So it's up to you. you want to measure continuous or actual value or discrete. Okay, it's up to the purpose of your measurement. Okay, to get the actual value, okay, so you can use continuous RMS. Okay, continuous RMS value. So it will measure direct from current measurement and it will display direct. Okay, the actual value. Okay, cross current measurement. Okay, so that's question number 1. And question number 2, let's say components that you need are not available, okay, in MATLAB Simulink library brochure. So what you can do? So far, based on my experience, okay, I've used MATLAB for my degree project, master research project, and for my PhD project. Actually, all are available in MATLAB library brochure, okay, Simulink library brochure. But if components or the function are not available, okay, in Simulink library brochure, means that you can create your own Simulink block. Okay, so how to create Simulink block, your own Simulink block? So you have to do some programming, okay, in order to perform, okay, in order to set the function of your block, your design block set actually. Okay, so you have to perform some programming actually to create your own block set. Okay, let's say if the components are not available in Simulink library brochure. Okay, I hope I can answer the answer. Can make you clear on how to use MATLAB Simulink. Okay. Okay, we just continue.
Okay, Dr. Rahimi, some more question.
Yeah.
Missing SIM power system in library. How to get the SIM power system and update in the library?
SIM power system.
Uh-huh.
So means that you have a problem with your MATLAB installation, MATLAB software. So means that you do not completely install your MATLAB tools or software actually. Okay.
Okay.
SIM power system actually common in Simulink library brochure.
Okay.
Other question?
Okay, another one. Usually, what kind of study need to use discrete measurement?
Normally, we use continuous RMS lah. Okay. So, for example, okay, so we use continuous measurement to get the actual value from this circuit. Okay, and we use discrete RMS. Okay, let's say if we want to measure from a signal block set, for example, step response and etc. Okay, from a single block set, we just continue to discrete RMS and then we connect to display.
Okay. Okay, one more. Can you please share when I will use continuous power GUI and discrete power GUI?
Continuous power GUI and discrete power GUI.
Power GUI.
I'm not sure about discrete power GUI, but for Simulink, we use continuous power GUI.
Okay.
We use continuous power GUI.
Okay, so far that's all the question. You can proceed, Dr. Rahimi.
Okay, thank you. So we proceed with PWM generation. Okay, how to generate PWM in MATLAB Simulink. Okay, so you can model in a new model, a new Simulink window, or okay. So to open new page, you just click add new model. Okay, just click add new model. Okay, again, we can find any components at Simulink library brochure. Okay, click at library brochure. Okay, click at Simulink and select sources and select constant. Okay, at sources, okay, select constant and just perform click and drag procedure. Okay, we have constant here. Okay, so again, at Simulink library brochure. Okay, still at sources. Okay, select repeating sequence. Okay, select repeating sequence block set. Okay, so please select repeating sequence block set and just perform click and drag procedures. Okay, so you can select at Simulink. At Simulink, so select logic and bit operations. Okay, at Simulink, select logic and bit operation and select relational operator. Okay, so select relational operator. Then just perform click and drag procedures. Okay, our objective actually to generate PWM. Okay, path with modulation. Okay, so now you can double click at relational operator. Okay, you can double click at relational operator. Okay, so since you click at relational operator, there are a lot of functions actually. Okay, less or equal. Okay, greater equals or greater. Okay, greater than. Okay, so for this example, just select greater and equal. Okay, greater and equal. Okay, so now how to set the repeating sequence. Okay, the repeating sequence actually you can set your switching frequency. Okay, circuit switching frequency at repeating sequence. Okay, to represent carrier signal. Okay, for example, if you want to generate PWM, okay, path with modulation at 5 kilohertz switching frequency, for example. Okay, so we can set this 5 kilohertz switching frequency at repeating sequence block set. Okay, so how it works actually? So based on this equation, okay, T equals to 1 over F. Okay, time equals to time for one full cycle equals to 1 over F. F actually frequency. Okay, in this example, switching frequency. Okay, let's say we set switching frequency is 5 kilohertz. Okay, so we just insert F equals to 5 kilohertz. Okay, so T equals to 1 over 5 kilohertz. So means that you will get T equals to 0.2 millisecond. Okay, 0.2 millisecond. And we have to set a repeating sequence. Okay, repeating sequence. Okay, this block set. Okay, with these parameters. Okay, we have to set, okay, starting point, okay, intermediate point, and the end point. Okay, so we have to set these 3 points. Okay, point 1, point 2, and point 3. Okay, so we know that for 5 kilohertz switching frequency, T equals to 0.02 milliseconds. So means that we have to set repeating sequence 0 and then one full cycle 0.2 millisecond. And at the middle 0.2 divided by 2. So we know that this point equals to 0.1 millisecond. Okay. Right. So now you can set a repeating sequence with these parameters for 5 kilohertz switching frequency. So in MATLAB simulation, there are no millisecond. There are no milli. So means that you have to insert 0.002 or 0.001, okay, to represent milli, right? 0.002, okay, for 2 millisecond. 0.2 millisecond. Okay, so how to perform PWM generator? Okay, so how to generate PWM? So this is the basic concept to generate PWM. Okay, so we compare carrier signal with modulation index. Okay, to generate PWM. Okay, so using MATLAB simulator, carrier signal represented by a repeating sequence. Okay, so you have to set 3 parameters. Okay, so how to set 3 parameters? Okay, at time values. Okay, at time values. Okay, first you have to set equals to 0 and then space. Then 0.1 E minus 3. E minus 3 means 0.1 millisecond. Okay, 0.1 milli. Space. Then 0.2 millisecond. 0.2 E negative 3. Okay, so this is the procedure how to set 3 points of repeating sequence block set. And at output values, you can insert 101. Okay, 101 in order to get W-shaped carrier signal. Or you can set 010 in order to get N-shaped carrier signal. Okay, for this example, let's say we set W-shaped carrier signal. So means that you have to insert or set output values 1, 0, 1. Okay, then you click OK. Okay, then you click OK. And you can set modulation index. Okay, you can set modulation index at constant block set. Okay, so modulation index you can vary from 0.1 ranging up to 0.9. Okay, so for modulation index, let's say in this example you set modulation index equals to 0.5. Okay, so just connect all of this block set, then just insert scope. Okay, to observe the waveform. Then please set scope. Okay, as we have been discussed just now. Okay, at parameters, you have to set sampling time equals to 0.0001. Then you click run simulation. Okay, you click run simulation. Then you can observe PWM signal at scope. So this is PWM signal. Okay, so you can click at zoom. Okay, to zoom the waveform. Okay, PWM signal. Okay, so that's the procedure how to generate PWM. Okay, in MATLAB simulator. Okay, so we proceed to how to analyze signal from MATLAB simulator. Okay, so we just proceed to this exercise.
Dr. Rahimi, sorry.
Any question?
Okay, two questions. Okay, missing SIM power system in library. How to get this? Okay, that one have been answered. Does SIM script, SCRAPRE, electrical element similar with SIM power system in MATLAB 2019?
You can try, you can observe by your own actually. Okay, you can click at SIM what they call it, and then you can find components. You can find the components.
Okay.
Okay.
Okay, another one. May I know what is the function of modulation index?
For power electronic circuit, okay, modulation index you can vary actually. In order to control speed of DC motor and etc. Okay, you can control the speed pulse width modulation by controlling modulation index. Okay.
Okay, that's all. I think you can proceed.
All right. So we proceed to this exercise. Okay, so you can model this circuit. Okay, we have AC voltage source here. So this is basic rectifier circuit. Okay, we have AC voltage source and we have 4 diodes. So this is bridge rectifier. Okay, diode 1, diode 2, diode 3, and diode 4. Okay, and we have RC load. Okay, in parallel connection, we have resistor and capacitor. Okay, so we still have time or not? Betul sudah? I'm just brief the circuit operation.
Yes, you can just proceed.
Proceed, huh?
Mm-hmm.
Okay, so I think we have no time to wait, all of you, to draw the circuit actually. Okay, so I'm just show you how to perform analysis. Okay, circuit analysis. Okay, from MATLAB simulink waveform. Okay, so let's say if we model a basic bridge rectifier circuits. Okay, so we want to observe the quality of the supply current waveform. Okay, in terms of its total harmonic distortion level, and we can analyze the harmonic spectrum. Okay, in supply current waveform. Right, so we can set the parameters. Okay, let's say we set AC voltage source, peak amplitude 40 volt, and frequency 50 Hz. And we set the parameters for resistor and capacitor. Okay, 300 ohm and 1000 microfarad. Okay, and we can set the initial capacitor voltage. Okay, in order to perform steady state operation. Okay, just click at initial capacitor voltage and we set the capacitor initial voltage. Okay, let's say we set capacitor initial voltage equals to 37.7 volt. Okay, since you have set the parameters for RC load, then you click OK. Okay, so we have to set at scope. Okay, do scope setting. Okay, so just double click at scope. And then click at parameters. Okay, click at parameters. And click data history. Click at data history. And tick save data to workspace. And at format, we select structure with time. Okay, if you want to copy this waveform from MATLAB into Microsoft Word, as I mentioned, we have been discussed just now. So we set format to array, right? So this waveform will appear at workspace. Okay, MATLAB workspace. But if we want to do analysis for this waveform, at format we set structure with time. Okay, we set this scope structure with time. Okay, since we set this scope structure with time, then click OK. Then we click run simulation. Okay, run simulation. And it will appear, this is the supply current waveform. Okay, so this is distorted supply current waveform. Okay, so this is in time domain. Okay, in time domain, distorted supply current waveform. And from this waveform, we know that this distorted supply current waveform reach of harmonics. Okay, that could lead to high total harmonic distortion level. Okay, so now how to analyze this waveform. Okay, so how to do analysis on this waveform? Okay, I mean supply current waveform. Okay, so just double click at power grid. Okay, just double click at power grid, and then select FFT analysis. Okay, fast Fourier transform analysis. Okay, just select FFT analysis. Okay, so you can select input signal, input waveform. Okay, so this is the distorted supply current waveform. Okay, and you can set the parameters. Okay, fundamental frequency we set 50 Hz. Okay, fundamental frequency 50 Hz. Then we can set maximum frequency. Okay, so means that we can maximum frequency, actually in this example we set to 2000 Hz. So what is mean? What is mean that it means that, okay, we want to analyze the harmonic spectrum up to 40 harmonic. Sorry. Okay, so we want to analyze harmonic spectrum in this waveform up to 50 harmonics. Okay, start from fundamental, third harmonic, fifth harmonic, 7 up to 40 harmonics. That's why maximum frequency we set 2000. So 2000 divided by 50 Hz. So means equals to 40. Okay. So in this example, we want to analyze the harmonic spectrum in this distorted supply current waveform up to 40 harmonics only. Okay. Then since we set the fundamental and maximum frequency, then you click display. Okay, you can click display. Okay, so look at FFT analysis. Okay, so it will show the total harmonic distortion level for this waveform. Okay, for this supply current waveform. Okay, so look at this value, the total harmonic distortion level, THD level equals to 252%. Okay, 252%. Okay, so from this waveform, we know the THD level equals to 252%. And we can analyze the harmonic spectrum, okay, in this waveform. Okay, so at FFT analysis, so we know the second order harmonics represented by H2. H2 actually for second harmonic, H3 for third harmonic, H4 fourth harmonic, fifth harmonic, and up to up to 2000 Hz or 40 harmonics. Okay, that's how to analyze waveform, okay, in MATLAB Simulink. And these parameters actually you can include in your technical report and etc. Okay, technical and in your thesis lah. Okay, for reporting. Okay, so this is THD level and fundamental, third harmonics, and etc. Okay, second, third, fifth, and etc. Okay, right. So we proceed to circuit subsystem. Okay, how to create circuit subsystem. Okay, so when we use subsystem actually, okay, so the main objective we create subsystem actually in order to optimize the large model by breaking into a hierarchical set of smaller model for easy in implementation. Okay, for example, if you click at the block set, okay, subsystem, and in subsystem it consists of several subsystems. Okay, so means that we can optimize the large model of our simulation circuit. Okay, so how to create subsystem? Okay, for example, Okay, so we have sine wave here. We have 2 compared to 0. So actually this is what we call it, phase detector circuit. Okay, so this is phase detector circuit. So first, how to create subsystem for this circuit. Okay, so first you have to disconnect this circuit from the scope. Okay, disconnect to the scope. Okay, then you have to select component that you want to create subsystem. Okay, so select all and right click at the component. Okay, you select all of this component and you right click at the component. Okay, and it will appear this dialog box. Okay, so at this dialog box you can select create subsystem. Okay, create subsystem. Okay, since you select create subsystem, and it will create subsystem for phase detector circuit. Okay, it just appear block set only, single block set only. Okay, compared to previous one, okay, it consists of 1, 2, 3 block set. Okay, so when we create subsystem, it just appear single block set only. If you double click subsystem, it will appear this circuit. Okay, this block set. Okay, so you can create a subsystem, okay, in another subsystem, and etc. Okay, so that's how to create subsystem. Finish. Okay, so that's for basic MATLAB simulation. Any question? So that's all. So any question if you want to ask?
Okay, anyone would like to ask Dr. Rahimi any question? There is no more question in YouTube.
I'm also feel hungry.
Okay, can MATLAB do frequency domain simulation?
Frequency?
Domain simulation.
Frequency domain simulation. What is mean by frequency domain simulation?
Not sure. Maybe the participant can ask directly to Dr. Rahimi.
You can email to me your question.
If you want to speak to him now, you just unmute yourself and you can just ask now. Okay, another question. In my model, I can't connect resistor with the AC source.
Okay.
That's all we asked.
If you cannot connect resistor to AC source, I guess maybe you use resistor from electronic tools. Okay, electronic block set. Okay. So you cannot interface between electronic block set and sim power system block set. Okay, so you have to select resistor from sim power system. Okay, as I mentioned just now.
Okay. Can I use more than one subsystem by this method?
Yes, of course.
Okay.
You can create subsystem under subsystem. No problem.
Okay. Okay. Participant requested for the presentation slide.
Okay.
Can we have the slide and the organizer will email to the participant?
Yeah, I will share with organizer after this.
Okay.
No problem.
Okay, this one is not a question, it's a request. Cancer will take another webinar regarding optimization tool, how to use, basic, etc. So maybe we can invite again Dr. Rahimi to have a second session, second workshop on optimization tool.
We can discuss it.
Okay. Okay, in 2019B, there is no SIM power system. What you suggest in this case?
You can explore actually. Maybe they use another names, different names. Okay, you can explore. Basically, okay, SIM power system actually 2019 actually I have no problem to find SIM power system. It's similar to the version.
Okay, next, can MATLAB use to do protection study?
I think anything can be done using MATLAB.
Okay, what version of MATLAB Dr. Rahimi used?
Actually, this is not prepared in 2009. Okay. So this is for 2006, I think. 2006. Okay. There are no problem actually to use a latest version of MATLAB. Okay. Basically, the same approach, the same methods. They just update features and etc. only.
Okay. Okay, there is no more question in YouTube and no more question here also. So any last question maybe from the participant? Anyone would like to ask anything else? It's already 11:40 now in Malaysia.
Lunch hour right now.
Lunch hour, no fasting.
Okay. Any other question?
Mm-hmm.
Okay. So if you have more question, thank you very much.
Okay, thank you so much on behalf of IEEE PES Malaysia and UiTM Student Branch. I really would like to say thank you to Dr. Rahimi for the sharing session of basic MATLAB. Maybe we can organize another MATLAB continuation from this session. So for the participants, the organizer will email the presentation slides and the link from the YouTube. And with that, on behalf of UiTM Student Branch and PES Malaysia, I would like to thank all participants for sacrificing your morning. I hope everyone have benefit from Dr. Rahimi's sharing session just now. Okay, from me it's all. That's all. So I will pass it back to Dr. Harun. Thank you so much. Assalamualaikum. Dr. Harun.